Nintendo Switch, check out, see what's going on. The first thing you always want to check on these devices is the port, because if you try to put power to test the Nintendo Switch into a compromised port, you can catastrophically damage these devices. Always check your port first. And Houston, I believe we found the problem. We have the board out of the housing and we are prepared to remove the port, but before we do that we need to turn on our equipment. And while I turn on my equipment, put up our expected temperatures for this job. And these temperatures are brought to you by the Amazon associate links in the description. If you click on one of those links and buy any of those pieces of equipment or buy anything on that list, a small portion of that purchase will go to supporting the channel. It would be greatly appreciated. Won't cost you an extra dime. And we're back to microscope. Let's flood our anchors with flux. Now we will flood our anchors with Loma. So what do you think, folks? Let's gamify this a little bit. Will we have secondary issues? Will we have full pads? Will we have blown chip? Post in the comments below your guess. Gentle pull, and it's a nice clean pull. Excellent. Let's investigate our pads, and the main thing I want to see is, one, do we have any pad damage? And it does not appear we do. And two, do we have any bridges? And it does not appear we do. We will begin our testing around the M92T36, and the first thing we want to test is our capacitor right here, which is tied to Pi 3 USB on the back through the M92T36. The line we do not want short to ground is this one going to the chip. And it is reading short, so we very much have a Pi 3 USB problem. Here we go. There's number one, collateral damage is the Pi 3 USB. Let's finish our testing around the M92T36. Follow the lines from the chip, from the capacitors to the chip. And we do not want those lines short to ground. The exception in this case is this capacitor right here, which has two lines going to the chip. One side will always be ground in that case. Alright, here is our CPU capacitor, the line going to the chip, and we do not want that short to ground at all. Very good. So we may have avoided catastrophic damage. Let's check around our MOSFETs. They seem to be okay. Let's check our invincible fuse and see if it's still being invincible, and it is. It did not prevent any damage. Pretty typical of that fuse. Now let's check our test pads. None of these test pads here should have a pathway to ground. And none of them do. Excellent. We should not have a pathway to ground on this coil, but we should have continuity through the coil, and we do. Find ourselves another ground, and same rules apply to the BQ24193, except that it has several capacitors with multiple lines going to the chip, so you just got to know which ones to test. And it looks like we're okay in this area. Now we need to switch over to the Pi 3 USB, which we already know has a problem. But does it have any secondary problems? This is entirely possible. So let's check our filters. And with the filters, we want continuity through them, but we do not want continuity side to side. Up and down, not side to side. And it doesn't matter which orientation, upside down or right side up. The chip is, same rules apply. Little trouble getting through the gunk. This filter may be bad, and it appears our little filter is dead. Okay, and we already know we're going to have a short on the big capacitor with the line going to the chip is one side we want to test, and it is dead shorted. Okay, so we do have two problems here. The Pi 3 USB chip is bad, and this filter has blown. So we must deal with that problem. Mouth. Go ahead and remove our little filter. Now let's test again. And our short has been relieved. Excellent. Getting them into place. I'll be dropping the airflow to 20% on the choke just to get it tacked down. And then when we put the Pi 3 on, we'll flow that into place fully. Okay, it's tacked down. Now we'll do our Pi, and hopefully that little filter will flow into place as well. Yep, we just flowed it. And now we'll press apply. Okay, remove the heat. Let it tack down. And then we press. Reapply heat. And press to flat. And now we are flat. just a tip, guys. I know it looks sexy to get the solder up to the alignment marks, but that's what those are, is alignment marks. It is not necessary to get solder to climb up to the alignment marks, and you can oftentimes get yourself into more trouble than it's worth trying to make it look sexy. Just remember, as long as it's flat to the board and it's aligned, you are connected. You're good. And real quick, we'll test again and make sure our short has not returned. It has not. And we'll check our little filter, make sure everything is copacetic there. Excellent. Our next order of business is to clean up and put a new port on. How many of you got it right? Of course, we don't 100% know for sure yet. The last pad here appears to be a little bit oxidized, so I'm going to do some very gentle scraping on it just to get that oxidization off. It is really lightly going over it. One of the many fantastic things that the grinding pin can do. Now we're going to place a ball of our Kester 44 6337 solder on our micro pencil tip, and what we want to do is we want to go over the pads with the ball primarily. You'll make incidental contact with the iron, but you're not really rubbing the iron along the pads, you're rubbing the ball across them. And that's how you get the nice puffy pillows. And again, we will apply a ball onto our tip, and same deal. We'll just go over the pins with the ball. Not really trying to make much contact with the iron. Really just want to make contact with the solder. Much less likely to have burning or melted plastic as well. Excellent. And we'll place our port. And as always, my method differs a little bit different from other methods you see on the internet. I will be using rapid air movement, and what I'll be doing is raising the temperature of the board enough to wet the solder of both the visible pads and the hidden row. And by rapidly moving our nozzle, we will not ever have the heat in one place long enough to burn plastic. It works for me. Find the method that works for you. I have tried the other methods like the hot swapping and stuff like that, and I just don't find I get as consistent of results with that method as I get with this one. So this is the way I do it. And you'll find that I do most ports in this fashion, including HDMI. Zoom in on these pins so that I can watch and press down and remove. And we'll hold the port down until we see the pins dry. I'm reasonably certain we've done alright, but one way to find out, we will now perform a very gentle nudge test. When you perform this nudge test, this port should not move. I would not, get ham-fisted without it. I'm just lightly tapping it. If you've only soldered one row of these pins, you will get some play here. When you're concentrating on getting that hidden row down, sometimes you can neglect these guys, so it's always good to check and make sure. And they are solid. We will flood our anchor points with flux. Place a ball on our tip. Start to get the flow. Ball. Excellent. We have good feed through from the other side of the board, and that port looks nice and solid. Next, I will clean off the board, and then we will come back when we're ready to perform some power tests. We're ready to perform some power testing. First thing we're going to test is with our dongle, our power dongle, 3.5mm to USB-C. This adapter is in the description. It has the right resistance to activate the switch most of the time. I wouldn't say it's 100% of the time. Let's see what we see. Okay, that looks relatively normal. We are looking at PSU channel 1, the amp meter. We want to see that on both sides. And sometimes it can be a little bit flaky. We'll try again. And I think it's just being flaky. And we'll grab our battery squid, our modified iPhone battery squid that we have retrofitted for Nintendo Switch. And for this activity, we will activate using the OEM. And what we want to see here is a steady current draw. or steady climb in current control. No hanging up. Okay, it does look like it's booting. So the next step in our testing is I'm going to activate the switch, or boot it up. Try to boot it up on battery. Okay, 0.47, but we want to see a reset here. Okay, now we want to see fast charging. Very good. So the switch is booting up. There we go. Excellent. We are docking. That is good news. We don't have to worry about, having to assemble it to dock. I love this little dongle. It is such a time saver. We're back up and running on its battery, and we are fast charging at 15 volts on the USB meter and 1.01 amps. We are charging our Joy-Cons. Now we want to test our wireless and make sure we're getting Bluetooth, and we are. Let's make sure we're picking up our wireless. All right, and we're picking up our networks. Excellent. Fan is spinning. And if you like this video, do me a favor and check out this next one, and I'll see you there.